Good morning, good afternoon, and good evening, wherever you are in the world today. I'm Ben Potter, the security lead of Well Architected, and I'm going to walk through some of the updates to the security pillar and key best practices. We'll start with a brief introduction to Well Architected for those who are not familiar, and a demo of the tool in the console, which will help to review your architecture. Then we'll cover the key best practices in the different areas of security, starting with security foundations and ending with incident response. The first link here is where you can find all the content, including the updated white papers. Second link here is the tool, which you'll also find in the AWS console. The third link is the link to our open source labs that help you learn how to apply the best practices. There are 5 pillars that make up Well Architected. We start with operational excellence, which covers how you develop and run. Then we lead into security, which we'll be focusing on today. Then we move on to reliability, performance efficiency, and cost optimization. So of course, we're only focusing on security today, so go and check out the links that I had previous to see what you can cover off in the other pillars. So why Well Architected? When investigating a new framework or guidance, you'll think about why. We've seen customers benefit from the advantages by using Well Architected, like build and deploy faster. So by reducing the firefighting, capacity management, and by using automation, you can experiment and release value more often. Lower or mitigate risks. So understand where you have risks in your architecture and address them before they impact your business and distract your teams. Make informed decisions. Ensure you have made active architectural decisions that highlight how they might impact your business outcomes. And of course, learning AWS best practices. Make sure your teams are aware of best practices that we have learned through reviewing thousands of customers' architectures on AWS. We have security design principles that you should have in the back of your mind at all times. So approach every problem with these. So we start with identity and access management, which is implementing a strong identity foundation, enable traceability, which is logging and monitoring, applying security at all layers, which is a defense in depth approach, automating security best practices, which is automating everything to implement best practices and using automation throughout your workload. Protecting data in transit and at rest. And of course, this is where encryption comes into things. Keeping people away from data is incredibly important. Preparing for security events, and this is incident response. The Well Architected tool is in the console, has no cost, and provides a consistent way for you and your teams to measure what you're doing to the best practices. So I'm going to do a brief demo of the tool now. So I've signed into one of my AWS accounts and I've selected my region, which is Sydney up here, and I've gone into the Well Architected tool under services. I can now see this welcome page and I can then define a workload. And here I can enter a name. This is for my reference only. I can call it demo. I can enter a description of some meaning and I'll call this demo. An owner for my information, which I can make my name. Then some additional information to identify. So this is a pre-production or test. I'm going to select my region, select North Virginia. I can also do non-AWS regions if I'm reviewing a workload outside of AWS. Any account IDs, architectural design. It's really good to put a link in here if you have any designs, or maybe it's a wiki page, an optional industry information there. And select next. And I now have the option to select either the base Well Architected framework or the serverless lanes. So I'm just going to do the base Well Architected framework for now. And you can see here, I can start reviewing my workload, and I have a bit of an overview dashboard here, which is incomplete. So I'll start reviewing on the well-architected framework. And then I go straight into operational excellence. So we'll just collapse that up, go security, and you can see we have 10 questions here on security. So security number 1 is actually a new question and incorporates some existing and some new best practices. So you can see the question is asked, how do you securely operate your workload? And we have a description underneath here. And when answering this question, you can work with the rest of your team to understand if you're meeting these best practices, like separating workloads using accounts, securing your AWS account itself. I can also drill into further information here, and it will explain on the right-hand side. At the top there, I also have some links to helpful resources that can help you along your journey. And then I can save and exit. I won't go through all the questions. I'll let you explore those in your own time. And then we have our review screen now, has one high risk issue. I can then drill down into the actual framework here. And I have a risk around security question number 1. I can then drill down on improvement items and see improvement information. So let's drill down further. And here I can see further information on how I can improve separating workloads using accounts. And of course, I can use AWS organizations or think about using AWS Control Tower. So I'll just flick back to here. And of course, this review is saved at this point in time. I can then also generate a PDF report for information. So I really encourage you to go and check out the well-architected tool and generate your own reviews of your own workloads. So the first area that we're going to cover off is security foundations. And this aligns to that first question of how do you securely operate your workload that I just showed you in the demo. So I'm going to go through a number of key best practices for each of these areas. So starting off, we have a new best practice, which is separating workloads using accounts. So previously, we only talked about securing the root user of your account. We didn't actually cover anything to do with securing your accounts themselves. So separating your workloads using accounts is a best practice. For example, you could have a different account for the test environment for a workload, or a different account for the production environment of your workload. And then, of course, different workloads will have different levels of sensitivity. So you could separate different workloads in different accounts as well. To make this easier, you can use AWS organizations to manage these accounts and apply guardrails at the account level to restrict what those different accounts can do. For example, I can restrict mine to only be able to use the Sydney region. To make it easier to create these accounts and also securing the accounts themselves, I can use AWS Control Tower, which actually applies a number of built-in guardrails that I'll show you shortly and configures the accounts themselves to a secure baseline which follows well-architected best practices. And I have a couple of links down the bottom there. If you're not using Control Tower, you should configure the contacts that are appropriate for your accounts as well. So if AWS needs to reach out to you, they know where to get the account contact details from. A key foundational best practice that has not changed is identifying and prioritizing your risks using a threat model. I like to think that every threat has a method, that is the way the threat is actioned, the opportunity, so this could be the time or access and how the attack is accomplished, and a motive. So why would somebody want to perform that particular attack in the first place? And when designing your threat model, creating your threat models, Also think about the detective controls and how you test these in alignment to the threat model. So new key best practice as well for foundations is identify and validate control objectives. And that goes hand in hand with automating testing and validation of security controls in pipelines. So this is a new best practice about having objectives built from your own threat model, not just a list of controls to help you measure the effectiveness of your risk mitigation. Adding to that is the best practice of the automating testing and validation of security controls in the pipeline. And I already mentioned Control Tower. Control Tower actually has these built-in guardrails for you, and to a certain degree, by using its account factory, helps you build the security controls into your account baseline. Also, for determining what controls are the responsibility of AWS and ones that are your responsibility, like above and below the line, you can look at AWS Artifact, which has a number of different compliance frameworks like PCI, and you can get information on those different frameworks from there. Also down the bottom, I've got a couple of links there to helpful resources. An existing best practice we had was keep up to date with security threats and recommendations. So that is common vulnerabilities and exposures that are relevant for your workload, like your applications and modules that you're using. Social media is a really good way to keep up to date as well. Different forums. Also subscribe to blogs like the AWS security blog and the AWS blogs in general that I've linked to down the bottom there. And I actually find that looking at the AWS marketplace at the latest technologies from our partners can give me a good idea of what's going on out there in the industry as well. The next section is identity and access management. So let's go through the best practices. And identity and access management had the most number of changes in the well-architected framework. So if we go through, we have a new best practice on relying on a centralized identity provider. What we mean by this is to avoid using built-in IAM users and groups. We want every person that signs into the AWS console to go through a centralized provider. Now, this could be as simple as using AWS single sign-on, which makes it really easy to centralize your identity management for signing into AWS. So you have a single sign-on in the console. You literally click which account in your organization you want to access, and you're securely signed in. You can use the built-in credential provider, or you can federate to an existing credential provider that you might have, depending on what you want to use. I actually use it even for a small bunch of personal accounts because it allows me to generate credentials on the fly to use in the CLI. So it means I don't need any access or secret keys in my configuration in the CLI. And that also ties in with the next new best practice of using strong sign-in mechanisms. So these are MFA tokens, whether they're hardware or software, and it ties in also with configuring password policies. We have a new best practice around leveraging user groups and attributes. That is, if I was part of a directory, I would be part of a group in that directory, and I can grant the permissions based on that group or even the attributes of my credentials. And I have a link down the bottom there to attribute-based access control as well, so you can check that out. Also, a new best practice is using temporary credentials. That is credentials that are generated by the simple token service. So I only use credentials for a short period of time. And these would typically be used in my applications, like an EC2 instance will get temporary credentials automatically through the role that's assigned to that EC2 instance. Another new key best practice for identities is storing and using secrets securely. Now, we can easily achieve this by using AWS Secrets Manager, which integrates with different AWS services like RDS, Relational Database Service. So instead of storing the RDS password somewhere, maybe even in my code, I can store it in the Secrets Manager service. I can automate the rotation of that password, and I can integrate it with RDS very easily. And I have a link down the bottom there to Secrets Manager. An existing best practice is auditing and rotating credentials periodically. So what we mean by this is if we are storing passwords like the RDS one, we should be using a service like Secrets Manager to rotate them. And of course, we have an audit trail when we're using CloudTrail. A new key best practice for permissions is defining permission guardrails for your organization. So think of permissions that can apply at the account level, your AWS account level, using organizations. An easy way to do this is to use Control Tower, which I previously mentioned. Here is a screenshot of a number of the built-in guardrails already in Control Tower. And you can see the behavior on the right-hand side there can be either preventative, like a prevention, or detective guardrail. And of course, I can customize these and apply them either using Control Tower or AWS organizations. An existing best practice we had around permissions was granting least privilege access. And tying in with that is a new best practice that we have of reducing the permissions continuously. And we can get an idea of what permissions are actually in use by using Access Advisor, which I have a screenshot of on there. So I can go into the role and then see what has been used in the past period of time, and then reduce that permission from the policy. A good way of reducing permissions to adhere to least privilege is using IAM conditions or condition keys. So this example I'm going to talk through is using a time frame and an IP address as a condition on an IAM policy. So you can see here I have the condition statement, I have a date greater than and less than, which is this year, and then I'm restricting to 2 different IP address ranges that can be accessed. And this policy can be part of a wider policy, and it can be applied to a role or a user or a group. A new key best practice for permissions is sharing resources securely. And that goes hand in hand with analyzing public and cross-account access. I can do this a number of ways. I can use Resource Access Manager to securely share resources across different accounts in my organizations, like VPCs. I can also use IAM Access Analyzer, which I have a screenshot of there, in determining what resources that I'm sharing outside of my account. So let's move on to detection area now. An existing key best practice for detection is configuring service and application level logging. So you want to enable logging everywhere you can. This is absolutely critical to getting visibility into your workload. And I have a number of different detective services in the center there, starting with Amazon GuardDuty, which will give me amazing insights. And I've got a slide on that coming up. And Security Hub, CloudTrail, AWS Config, and CloudWatch. We also have a new best practice around analyzing the logs and the findings that you generate and your metrics centrally. And this can be using a number of the different services there, or even using your own security incident and event management system, or a SIM or SIEM. So Security Hub recently announced a number of foundational checks. So these are foundational best practices, which include a number of well-architected best practices that you can enable in the console So I encourage you, if you're not already using Security Hub, to go and check it out and enable these foundational security best practices. And I've got a link down the bottom there that can help you. A new key best practice for detection is implementing actionable security events. So what we mean by this is, don't just send an alert to your security ops team if you're fortunate enough to have one, or an individual that looks after security in your organization, but actually help them out a little. For example, I can use Amazon Chime or my chat application of choice, and I've got an example of a message that I could send using the chat app. So in this example, I've got GuardDuty, I've got an instance ID, I've got the link here of the outbound port scan as the GuardDuty finding. So the person looking at this can go and know what an outbound port scan is. And then I've got also an embedded link to my runbook and an escalation process. And of course, a friendly ask your friendly SecOps team member if you need help with this. So this is much better than just spewing emails or alerts out and not having any action taken on them. So let's have a look at what you can look for detection and what you need to think about. So preparation is critical. So go back to your threat model, have a look at what your threats actually are, set your thresholds. For example, a DDoS of a public website, you need to set a threshold for what is normal traffic and what actually is a denial of service attack. Then have a look at what automation you can put around that, automating the investigation, even the protection, and how you actually dive into that. Also have a think about insider threats. So an insider threat you could detect by looking for reduced visibility. Have they attempted to, or have they actually turned off CloudTrail logging or any other application level loggings to try and cover their tracks? Have they transferred data outside of your accounts or outside of your organization? Are they leaving unused resources like a Lambda function, which might have code in it that could do something in the future? And of course, the social aspect. Is there anyone in your team that's been somewhat disconnected, especially in these uncertain times? And finally, reconnaissance that you need to think about. Is there any DNS level reconnaissance happening? Are there any weird DNS requests that are coming through in your logs? Is there any access denied attempts? That could be 404s in your web application logs, or any amount of logins over time. Let's have a look now at a challenging detection event. How would we detect a credential stuffing attack? And credential stuffing is when somebody out there is going to try different credentials against your application to try and break into it. So I have this example here is an entry from a CloudFront log. So we have an IPv6 address there in red. We have what the method was, which was a post there in yellow, and we have the path or the URI there in blue, and the HTTP status there in green. So this request was accepted, and it was a request to the login page. So if you see a number of these over time, and again, this goes back to the threshold that you set from the same IP address or maybe the same user agent even, it could indicate a credential stuffing attack. And then I can tie that in with the graph here example of login success over time. So my login success of my application might hover around 90% normally, but then if I see a drop off, I should alert on that drop off. And you can see here it's gone down to around 20%. So this could indicate a credential stuffing attack where people are trying different credentials over a period of time unsuccessfully. A new key best practice for detection is automating response to events. So that is, don't just have detection capabilities and controls in place, actually automate that response to it, automate the investigation, and even automate the remediation. So for AWS resources, we can use a fairly new feature in AWS config, which is called conformance packs. So there's a number that are built in, and you can roll your own as well. And the screenshot here is an example of DynamoDB conformance packs. And I have a link down there so you can find out more information. Let's move on to the area now of infrastructure protection. A new best practice is creating network layers. Previously, we had control traffic at all layers. So creating network layers is in addition to that. We want you to create the layers and then control traffic within those different layers. And I'll step through a sample architecture of what I mean by this shortly. We also want you to implement inspection and protection in those different layers. Let's have a look what this could look like. So I'm going to build out a simple architecture now, starting with the internet and my AWS account. So a request coming from the internet to my web application is first going to do a DNS request, and this will be through Route 53. And of course, if I tie back into the detection capabilities, I can enable logging on Route 53 so I know what requests are occurring and anything that's coming from different locations or odd locations from my application, or an odd number of requests as well. The request then goes to Amazon CloudFront for CDN, and that I can tie in an integration with AWS Web Application Firewall. The AWS WAF has a number of new capabilities, has a new API, and a number of built-in rules, so you can easily get started now. And I'm going to have more on that a little bit later as well. So this provides really good protection at the edge layer before we reach into our VPC. So within my VPC, I'm going to have different layers using subnets. Here I have a public subnet. I have an application load balancer in that subnet, and that subnet has its own route table and network ACL. I haven't shown here the internet gateway. So this route table and NACL will allow me to get in and out of the internet easily from only this subnet. Drilling down into now the shared layer or the shared subnet, this is egress only. It doesn't allow any incoming traffic through the route table or the network ACL. It only allows outbound access. So it's a good place where I can put a network address translation or NAT gateway here. This NAT gateway can be used by my application layer. So this application layer allows only private access within my VPC and egress only via the NAT gateway. I could optionally use a proxy service there to further restrict what traffic and control the traffic that goes out, rather than just allowing all traffic out through the NAT gateway. And this application subnet also has its own NACL and route table. I can also use VPC endpoints in this layer as well to securely access services like S3 and Lambda in there as well. And finally, my last layer is my database layer. So this is private traffic only. It has no ingress or egress allowed, governed by the route table and NACL to the internet. And I can use the service endpoints in there as well. Automating protection is a best practice. So let's have a look at a web application firewall example of how we can automate protection. And this example is available on the solutions page on the link below and was recently updated to include the latest WAF release. So we start off, we have valid users on the left, and we also have attackers. And the idea is we want to block the attackers. So we have requests go through CloudFront to either or my application load balancer, and the logs go through Kinesis into S3 for further storage and analysis. Then I have Lambda log passes that are built as part of this solution that use Amazon Athena to determine from those logs, if there's any HTTP flood attacks or any scanners and probes, I can then build those out to go and block those automatically. I can also automatically obtain IP reputation lists off the internet, and they also plug into the WAF to block those recent IP list updates. I can then also have a bad bot detection by having a hidden URL hosted on API gateway in my web application, and then using a Lambda access handler to pass that request. So it's a really cool solution that's recently been updated. I highly recommend you go and check it out. It's really cool. Let's move on to the compute area of infrastructure protection now. So we had a previous best practice around reducing your attack surface. So this is around hardening. If you're using EC2, you should harden your machine images that you use. There's also pre-hardened images available for you. A new best practice is around performing vulnerability management. And that also ties in with another new best practice of validating software integrity. What we mean by these, and we had a previous best practice on just simply patching, but we want you to think more about patching, like the complete vulnerability management lifecycle, and also have a think about where you're getting your software from, and that it is actually the correct package that you're downloading. And you can do this by validating the checksums, for example. I have a couple of links down the bottom there to Systems Manager Patch Manager and Amazon Inspector. So Patch Manager will help determine what the patch levels of your instances are and help you actually patch them automatically, whereas Amazon Inspector is a great detective capability in looking for common vulnerabilities and exposures in your running EC2 instances, as well as your network reachability for VPC. Let's have a look at some example tools now we can use for vulnerability management. Should always scan the source code we're using and the dependencies for vulnerabilities. We can consider using the open source OWASP dependency check tool, or dependencies checking is actually built into a number of different packages as well. Should also think about fuzzing. So if you take the example where we've got a web form that takes an email address, does that form only allow email addresses, or can I actually insert, say, HTML code in it? So it's very important to test this by fuzzing your application, and there's some example open source tools there. Also, a very common open source tool is the OWASP Z attack proxy, or ZAP, that can help test your application or web application. A new best practice for infrastructure protection is enabling people to perform actions at a distance. So what we want you to do here is not directly access systems like an EC2 instance, even if it's through a Bastion host. You shouldn't need to log directly into something to investigate or manage it. Instead, you should be using, and I've got a link down the bottom here, like Systems Manager Run command. So you can have pre-built commands that are peer-reviewed and run automatically against a single or group of instances instead. Existing best practice we had was implementing managed services. So if you have a look at, say, RDS, Relational Database Service, that takes care of the operating system patching and the management of the database engine itself as well. So that's going to save you a lot of time that you can spend to secure other parts of your workload. You should also automate compute protection. And we also have a preview that was recently released and linked down the bottom of CloudFormation Guard. So you should go and check that out as well. The previous architecture that I showed, we actually have built CloudFormation templates, and these are available through the well-architected labs for both the VPC and an example WordPress application as well on these links here. Let's have a look now at the area of data protection. Existing key best practices for data protection are identifying the data within your workload. So that is knowing what you're actually storing and the classification level of it. For example, if I only got a public facing marketing website with public classified data, or have I got a legal documents that I need to appropriately secure. And another existing best practice is automating the identification and classification. And this is where Amazon Macy is going to help you determine what data you have by using machine learning against what you're storing in Amazon S3. A key best practice is also keeping people away from data. And this is also one of our design principles. So let's have a look at a few things that you should think about. So don't actually store the data in the first place if you don't need it. And also don't grant permission to anyone if they don't need it. Next, I should think about if I do need to store the data, encrypting. Encryption should be on all data at rest and in transit at all times. Also, masking and tokenization might be appropriate as well for this data. I should also isolate the data so it can't be touched or manipulated by the wrong people or a different system that it shouldn't be. And of course, I can use KMS, the key management service, to help me here. Next, I can think about tooling. What tooling can help me manage this data? What automation is built in? For example, S3 lifecycle policies. I want to also eliminate direct access to that data, keep it completely isolated so nobody can access it. Of course, it depends on the sensitivity level of this data as well. I should then, if I need to do anything to the systems that control this data, I should do these with actions at a distance that I previously mentioned. And I can do this using a version control system. So actually controlling the systems in a pipeline. And I have an example of a DevSecOps link down the bottom there that you should follow and go and check out. Existing key best practice for data protection is enforcing encryption at rest and in transit at all times. And an easy way to do this for EBS, as an example, is tick this box in the console. And you can follow the link down the bottom there of how to do it. So ticking this box enables any new EBS volumes to be encrypted with that particular encryption key. And it can be the default key or your own custom KMS key. It's simple as that for EBS. And of course, you should go and check out the encryption options on the other services that you're using. A new best practice is auditing the use of the encryption keys. And you can accomplish this by looking in CloudTrail. And I have some links to KMS down the bottom there, as well as the awesome crypto tools, which include our encryption SDK. Right, let's think about unintended data access now. So unintended data access can originate from a host, software as a service, even a partner that we're using. So whether a consulting partner or a different type of partner, DNS, and also logs. And you should always think about the level of sensitivity of the data that you're storing in your logs as well. Another key best practice is automating the detection of unintended data access. For this, you should consider all sources of data. Also think about interesting API calls, and this ties back in with the detective controls and of course your threat model as well. And these should be any services that host data, whether it's S3, EC2, and so on. CloudWatch events can automatically take action using lambdas and other mechanisms on the data for these interesting API calls that you define. Also want to think about the S3 access logs, and this can be from S3 or through CloudTrail, and you can actually customize the access information that is in there. So this example here, I've got a request to a puppy photo, and I've simply put in a query string, which is Xcode, and an example, which can be anything I want. So I could look for requests in my logs that do not contain this and treat it as a detective mechanism for the unintended data access to the objects in that bucket. The final area that we're going to cover today is incident response. Let's step through the key best practices for incident response. We have identifying key personnel and external resources. That is, who in your organization can help you during an incident, and do you need to get outside help from a partner to help during an incident? Having incident management plans. This is actually a modified best practice that used to be just incident response plans, but it may be that your organization also needs escalation plans or public relations related plans as well. Pre-provisioning access and tools into your AWS accounts. That is, if you have a security operations team or function, that they have pre-existing access to at least read all your different AWS accounts. Of course, it depends on the data sensitivity there. You should also have pre-deployed tools like Amazon Detective that I'll be demoing shortly. You should also run game days or simulations for different events to help practice your incident response capabilities, and find them really good for determining any gaps that you have in your detective controls, and everyone learns a lot from these. And of course, it doesn't have to be a whole day. You can do it for a couple of hours at a time. Also, being prepared for forensics if you need to, and it might be that you choose to use an outside vendor for forensics. And finally, a new best practice we have is automating containment and recovery capability. Previously, this was just automating response. What we want you to do here is think about how you can automatically contain an incident so it doesn't do any more damage. For example, you could have an organization service control policy that just blocks specific access to an entire AWS account that you could have under investigation. So nothing in that account can do any more damage. You can then assess the account and the information, go through the logs, and make a more informed decision at that point in time. I like to recommend using GuardDuty as a starting point, because especially in building your incident response plans, because it has a bunch of findings and it may be the first place that actually detects an incident and how you go about the investigation of it. So the data sources for GuardDuty currently are VPC flow logs, DNS logs in your VPC, and CloudTrail events. So these are analyzed using threat intelligence feeds, machine learning, and anomaly detection. And then they're given a ranking of high, medium, or low. So it allows you to take appropriate response to the alerts that are generated. I like to use this formula of GuardDuty with your runbooks, practice through game days or simulations. Involving partners can help you sleep a lot more at night. We also have an updated incident response guide that was updated last month, and some new example open source runbooks that you can check out on GitHub using that link there. How do you actually run a game day? Well, it's a little bit difficult to do it in person at the moment, but you might be able to do a virtual one. So you should schedule a time. Like to find a prize, so somebody gets something out of it. Have food or drink if that's appropriate for your current circumstances. Pick a GuardDuty finding, create a little playbook or a run book about it, and actually learn and make a bit of fun out of it. It doesn't have to be a closed session where a team is trying to detect the other team. It could be completely in the same room and made into a fun event. Right, I'm going to demo now Amazon Detective. So Amazon Detective, I find, is a really easy tool to actually investigate an event, and it might be a security incident. So it actually pulls in and collects the log data from different resources like CloudTrail and VPC flow logs, and it puts it all in the one place for me. So normally you'd have to go into the logs and log dive individually, whereas with Detective, it just has it all there indexed and collated for me. So let's go into the search here, and I like to search for a GuardDuty finding. I've even got, I can insert a particular GuardDuty finding ID here, or I can pick an example. So let's drill down an example for. So this finding was this instance ID was communicating with a disallowed IP address, and I can drill down and find more information there. And this was the actual GuardDuty finding. And this is the time that it occurred. So if I scroll down, I can look at the further details on this. So the direction was outbound because it was this instance reaching out to a suspicious IP address. I've got my account ID, local IP address, port number. So it's getting all this from the VPC flow logs. Scroll down, and this is the remote IP address in question. Then I can drill down on that and see when the first observed, last observed time. So it looks like it's been occurring for quite some time. Number of times that it was observed. So you can see I've just used that IP address as the pivot point, so I can drill down and find more information. And if it's had any API calls from CloudTrail, then they'd be here. But you can see there's no failed or successful API calls from this IP. So it's just an external suspicious IP. So we'll just go back now. Let's have a look at another GuardDuty finding now. So at this point in time, it was a penetration test which appears to be related to Kali Linux. So we can find my GuardDuty finding details, the role details related to that, and any findings associated with that particular role. So you can see here we have the API calls because this was a role that was found conducting these penetration tests. So you can see how powerful it is to drill down and pivot from the different data sources here without having to grep masses of logs and try and correlate them yourselves. So I really encourage you all to go and check out Amazon Detective and try it out. Let's cover now how you can take action from what you've learned today. You should go and check out the new content and resources on the main well-architected page. Go and review your workload or re-review if you have an existing one with the latest best practices. Check out our open source hands-on labs, and you'll find a pre-built collection of solutions and also solution constructs on the final link there that will help you build on AWS. Thank you for joining today.